Now, the direct comparison test is one that's very useful, and it really gets more and more useful the more different kinds of convergence tests you know. The idea is pretty simple. It's that if I have a series that I can show is less than another series I know to converge, then my series converges. If I have a series that's greater than a known divergent series, then my series diverges. So you kind of use the ones you know and the ones that are easy to use. For example, this first one you've got 1 over n minus 1. I mean, an easy comparison, I'm just going to write a comparison, would be 1 over n, which we know diverges. Let me explain what I mean by that. Let's think about, from 2 to infinity, let's think about some terms here. So 1 over 2 minus 1, so we got 1 over 1, plus 1 over 2, plus 1 over 3, and so on. Whereas this comparison series, I'd have 1 over 2, plus 1 over 3, plus 1 over 4, and so on. Starting at 2, just like the other one did, and going to infinity. Well, if you look at these two, they do have a lot of like terms, but this has the 1 in front. So what I can say is that 1 over n is actually less than 1 over n minus 1. Well, if 1 over n is so big that it diverges, and 1 over n minus 1 is even bigger, then this must diverge. Okay? And that's the direct comparison, where we pick something and we compare it. Now, of course, using 1 over n, because it diverges, I can only prove divergence with it. And that's kind of the message here. You can only prove divergence with a divergent series. You can only prove convergence with a convergent series. So I couldn't look at this and say, 1 over n plus 1, that's small. That's smaller than 1 over n. Well, that doesn't help us. That's not going to compare. We need to use this comparison as written. So we can't prove that something is less than a divergent series and converges. That isn't going to work. Okay. Now this next one, I haven't left myself a lot of room, so let me compare to 1 over n squared. Again, a lot of times it's obvious. It's an obvious thing what you're going to pick. We know that this converges. Okay. So if I started writing terms down again, 1 over n squared plus 1, so 1 over 4 plus 2, so 1/6 would be first. 1 over 3 squared plus 3, so 1/12. I'll do one more. 1 over 4 squared plus 4, 1/20, like that. Whereas this other series would be 1/4 plus 1/9, and so on. Obviously, the red series is bigger than the black series. So 1 over n squared is bigger than 1 over n squared plus n. And since 1 over n squared converges, 1 over n squared plus 1 must also converge. Very similar to the squeeze theorem and sandwich theorem, where if we can prove that something is being squeezed below something that converges, we can show that it also converges. Be very careful with this test. As I said, you can't prove, you can't take a divergent series and prove convergence, ever. You can only prove that, you've got your divergent series, everything above it must also diverge. You can only prove convergence with a convergent series. So you can have your convergent series and show that everything below it or less than it also converges. And you have to be very, very careful with that.